Nursery crop production in the United States is primarily concerned with wholesale and retail sales of woody ornamental plants such as trees, shrubs and vines, ground covers, and sod for establishment of turf. In addition to ornamentals, nursery growers have expanded to sell fruit and nut trees, plus small fruits and perennial vegetables. The nursery industry is one of the fastest growing segments of agriculture, with California being the leading state for production and Florida being second. I'm Dr. DeBusk, and this video provides information on nursery development and facilities required for a successful nursery operation. Strategically organizing the nursery layout is important to maximize the production of crops. The two main types of nursery layouts are container and field nurseries. A container nursery grows nursery crops to a marketable size in containers at different size and shape according to the species and the marketable size desired. Container nurseries require 2 or 3 times less land per plant than field-grown plants. After the nursery layout has been established, the land must be prepared properly. A field nursery grows nursery crops to a marketable size in the field. After the nursery layout has been detailed and properly planned out on paper, the next important step is land preparation. Major objects such as trees, stumps, and other debris should be removed and the land should be leveled. After the land is leveled, irrigation and drainage systems need to be installed as necessary. The road system should be installed to provide ample space for movement of nursery stock, equipment, and personnel. A variety of structures are used for propagation and subsequent growth of nursery crops, including potting areas, greenhouses, cold frames, hotbeds, shade houses, and overwintering structures. Potting areas should be centrally located and free of disease and weeds. Greenhouses have the best environmental control for growing plants. However, they are the most expensive. Cold frames consist of a wooden or concrete block frame with heat supplied by solar radiation through glass or another transparent covering. This is the simplest and most economical outside propagation structure. Hotbeds are similar to cold frames, except that electric or hot water is used for heating. Shade houses provide plants from environmental factors such as wind, temperature, hail, heavy rains, and solar radiation. Overwintering structures have a permanent frame, can be produced in a variety of sizes, and are covered annually with polyethylene to prevent nursery crops from being damaged during the winter months. The coverings are typically removed during the summer months to prevent heat buildup. This type of house can be constructed at lower investment costs than greenhouses and is the reason for their popularity. In addition to having structures for propagating and growing plants, a nursery needs a cold storage facility, a centralized building for shipping, office space, pesticide storage and mixing areas, and storage buildings. After selecting a nursery site, the first step is to run a marketing survey to decide what product mix, the types of plants to be grown, should be used. Typically around 70% of the plants grown should be common. Examples of standards are shrubs, roses, shade trees, red maple, flowering trees, magnolia, broadleaf, holly, and needled evergreens, juniper. The remaining 30% should be new plants that have potential but not high-risk plants. In the nursery industry, the trend is toward producing container-grown nursery stock because it is less labor-intensive. The grower has more control over the media used, and higher plant densities are possible. Another reason why container-grown crops are becoming more popular to consumers is that plants recover more quickly than field-grown crops after transplanting, and they can be marketed year-round. Some problems are due to the pots themselves. Water and fertilizer must be carefully monitored. Winter protection may be required, container and labor are costly, and root stress possibly causing them to be root bound. Because nursery crops are in containers for a long time, growing media and type of container are very important. A good propagation medium should firmly hold cuttings in place, be free of insects and diseases, have good water and nutrient holding capacity, and provide excellent aeration and drainage. The factors to consider for containers include size, cost, adequate drainage, proper color, weight, and ease in handling, while being durable to facilitate shipping and handling. Containers should be free of toxic substances and able to prevent root circling. Copper-containing pots can be used to prevent root circling. In container nurseries, beds are produced to enable plants that are similar in size and cultural requirements to be grouped together to maximize production. Beds vary in design and size depending on the size of the pots, container spacing, production practices such as fertilization and pruning, irrigation design, and coverage. After the site is leveled, there are two potential designs. One design has the center of the bed raised to allow any excess water during rain or watering to drain to the outside. A second version has the slope going toward the center of the bed to allow the water to drain out of the way of workers. Nurseries in many parts of the United States need to protect plants during the winter months. The roots of plants are not as cold hardy as the shoots, making container-grown plants susceptible to winter damage because the root system is not insulated by the soil like the roots of field-grown crops are. For sensitive crops or in areas where winter protection is required, there are many ways plants can be protected. One way to provide winter protection is to place pots close together and wrap them with plastic around the outside edge. Another way is to put a border row of containers filled with soil but no plants to protect the pots containing plants. A combination of the two methods, using plastic and border row of containers with soil only, can also be used to protect plants during the winter months. Overwintering houses covered with white polyethylene are frequently used for winter protection. Based on location, these overwintering structures can either have supplemental heat or only solar heating. A production practice that can be used to protect roots of plants against extremes in temperature is the pot-and-pot method. With this method, larger pots, holder pots, are placed in holes in the ground and buried up to their lips. Containers with plants are then placed into the holder pots. Using this method, there is typically no need to protect the roots from winter injury. During the summer months, temperatures in the ground may get too high, therefore precautions must be taken to overcome this condition at locations where high temperatures are a potential problem. This method is commonly done in Florida because it has an added benefit of stabilizing the pot more during windy conditions. Most growing media used in nurseries contain none or only a few nutrients, so it is important to use pre-plant amendments. Pre-plant amendments include dolomitic limestone, calcium and magnesium for pH control, and a controlled release fertilizer. The nutritional status of the growing media in the plant must be regularly monitored through foliar and solar analysis. 3 types of media tests are available: electrical conductivity, EC, pH, and nitrate analysis. Fertilizers and other dissolved salts change the capability of a solution to conduct electricity. Pure water is a poor conductor. However, as salt content increases, the conductivity of the solution also increases. Today, portable conductivity meters can be used by the grower to measure the EC of the solutions. The growing media should be tested every 1 to 2 weeks for salts, nitrates, and pH. Portable EC, pH, and nitrate meters are excellent for this purpose. A chart of the pH, EC, and nitrate levels should be kept to determine when fertilization or pH control is necessary. Visual symptoms are not good indicators of when to apply nutrients because when symptoms appear, plant growth and development have already been adversely affected. If deficiency symptoms occur, quick-release fertilizers should be applied to get rapid results. Quick-release fertilizers must be applied in their proper amount. If too much fertilizer is added, it will burn the plant's root systems. And if not enough is applied, the deficiency symptoms will persist. Proper watering of container-grown plants is one of the hardest tasks for new employees to learn. Irrigation should be based on the demand of the crop, which can be determined in several ways. One way an experienced grower can determine when water is needed is by filling the weight of the pot or actually weighing the pot. Another method is simply to feel the growing medium, although it takes experience to know the correct feel. Indicator plants show signs of wilting prior to crop plants, thereby signaling when crop plants should be watered. Moisture sensors strategically placed in pots are also a very good method for determining when to water container-grown plants. Irrigation should take place during the early morning hours to minimize evaporative losses. On hot sunny days, it may be necessary to apply water more than 1 time per day. Pest control should be done using an IPM program focusing on prevention, such as using healthy plants as the first defense. The main difference between container and field nurseries is that field nursery plants are grown to a desired size in the ground instead of in containers. Good site preparation is vital for high-quality nursery stock grown in the field. The soil should first be tilled to loosen it, and any large objects that surface must be removed. Soil samples should be taken to analyze for nutrients as well as pathogenic soil fungi, insects, and weeds, so the proper control measures can be taken prior to planting. Organic matter and/or sand may need to be added to improve the tilth of the soil. Cover crops, also called green manure, can provide a good source of organic matter while preventing erosion. Depending on the location, it may be necessary to install drainage and irrigation systems. Plant spacing is another important consideration when deciding on the proper plant placement of nursery crops. The proper distance between the rows should be determined based on the final size of the plant because, unlike plants in container nurseries, after plants are in the ground, it is time-consuming and labor-intensive to move them. Another important factor to consider is the type of equipment required for harvesting and other nursery operations. For example, if plants are to be harvested by hand, less space is needed than if mechanical units are used. Another important factor to consider is the type of equipment required for harvesting and other nursery operations. Two major types of production systems are commonly used to remove crops grown in the field. The balled and burlapped B&B production system is when trees are grown in the field, dug up with a ball of soil surrounding the root system and covered with burlap material. This method minimizes transplant shock but is expensive. The second type of production system is the bare root method, which describes trees grown in the field and dug without taking soil. Smaller trees and shrubs are harvested using this method. In the bare root method, plants are lightweight and thus shipping is more economical, and the initial cost per plant to the grower is lower. However, the main disadvantage is a problem with transplanting shock, which is a period of no growth following planting. Properly maintaining field-grown crops is important for maximizing their growth and development. This is accomplished by routinely running soil tests to determine when to fertilize and how to adjust the pH to ensure that nutrients are readily available to the plant. Lime materials are applied to raise the soil pH. Agricultural limestone contains calcium, whereas dolomitic limestone contains calcium and magnesium. When liming agents are added, first they supply calcium and increase the pH, which reduces the effects of calcium leaching. Second, when dolomitic limestone is applied, magnesium is supplied, and phosphorus, molybdenum, and magnesium are increased. Third, the availability of aluminum, manganese, and iron is reduced, which decreases their harmful effects. Fourth, the pH change enhances favorable microbial activity, making essential elements more available for plant growth and development. Fifth, the soil structure is also improved. In areas where the soil pH is high, sulfur compounds are used to lower the pH. The correct moisture levels must be supplied after the nursery crop is planted, because too much or too little water will have an adverse effect. Supplemental irrigation is important during transplanting and establishment phases because in both of these phases, it has been shown to affect the survival and growth rate of field-grown plants. The proper way to establish an irrigation schedule for nursery stock is through the use of tensiometers or close evaluation of environmental conditions. In general, 1 inch of water is typically required to irrigate nursery stock after it has been determined that water is required. Pest control should be taken care of using a good IPM program. In conclusion, you now better understand nursery production in the United States in both container and field-grown forms and the steps necessary to develop the site and create the necessary facilities for a successful nursery.